Do you ever look up at the night sky and just short circuit? We think we've got a handle on things down here on Earth. We worry about traffic, what's for dinner, or that email we forgot to send. But up there is a reality so vast, so violent, and so utterly bizarre that it makes our everyday lives look like a quiet afternoon nap. The universe isn't just big, it's weird. It's a place where it rains diamonds, where a single teaspoon of stuff weighs more than Mount Everest, and where you can find clouds of alcohol floating in space. Today, we are starting an epic journey. We're not just scratching the surface. We're diving deep into 80 of the most mind-blowing facts about our cosmos. We've got a lot to cover, so grab your astronaut helmet, suspend your disbelief, and let's get started with the first 20. Fact 1. Space is eerily silent. First up, let's shatter a Hollywood illusion. Every space movie you've ever seen, from Star Wars to Guardians of the Galaxy, is filled with the roar of engines, the pew-pew of lasers, and massive window-rattling explosions. The reality? Space is completely, profoundly silent. It's a silence so deep it's almost impossible for us to comprehend. Why? It's all about physics. Sound, as we experience it, is a mechanical wave. It needs a medium to travel through. On Earth, sound travels by causing vibrations in the molecules of the air, water, or solids around us. Your voice causes air particles to bump into each other in a chain reaction that eventually hits someone's eardrum. In the vacuum of space, there is no medium. The vast distances between stars are an almost perfect vacuum, meaning there are virtually no particles to vibrate. You could detonate the most powerful bomb in history right next to your spaceship, and you wouldn't hear a single thing through the vacuum. Astronauts, of course, can hear each other inside their spacecraft or over their radios, because there's air in the cabin and radio waves don't need a medium. But step outside? Nothing. It's the ultimate silent treatment. Fact 2. The hottest planet isn't the closest to the Sun. If I asked you to name the hottest planet in our solar system, what would you guess? 99% of people would say Mercury. It makes perfect sense, right? It's the little guy huddled right next to the Sun. But you'd be wrong. The undisputed heavyweight champion of heat is the second planet, Venus. Mercury, lacking any significant atmosphere, is a planet of extremes. The side facing the Sun gets roasted to about 427 degrees Celsius, 800 degrees Celsius, but the side facing away plummets to a bone-chilling 180 degrees Celsius, 290 degrees Celsius. Venus, however, is a planetary furnace 24/7, all over its surface. Its secret is a nightmarish runaway greenhouse effect. Venus is shrouded in an incredibly thick, dense atmosphere composed almost entirely of carbon dioxide, a potent greenhouse gas. This atmosphere is so heavy that the pressure on the surface is 92 times that of Earth, equivalent to being nearly a kilometer underwater. Sunlight filters through the sulfuric acid clouds, heats the surface, and then it's trapped. The heat has nowhere to go. The result is a stable, crushing surface temperature of 465 degrees Celsius, 867 degrees east. That is hotter than Mercury's hottest day and hot enough to melt lead. Fact 3. A day on Venus is longer than its year. Let's stick with Venus for a moment because it just gets weirder. We're used to our own planet's rhythm. A day is 24 hours, and a year is 365 days. We go to work, we sleep, and we have hundreds of days inside 1 year. On Venus, that whole concept is flipped upside down. Get ready for this. A single day on Venus, one full rotation on its axis, takes 243 Earth days. But a full year on Venus, one orbit around the Sun, only takes 225 Earth days. Yes, you heard that right. Its day is longer than its year. If you could somehow stand on the surface of Venus, you would experience a day from one sunrise to the next that lasts 117 Earth days because it's rotating in the opposite direction of its orbit. Oh, did I forget to mention that? Venus has what's called retrograde rotation. On Earth, the sun rises in the east and sets in the west. On Venus, it spins backward, so the sun rises in the west and sets in the east. It's an incredibly slow, backward-spinning, hellishly hot pressure cooker. Our sister planet is truly the stuff of nightmares. Fact 4. There are more stars than grains of sand. This one is a classic, but the sheer scale of it is difficult to truly internalize. We've all been to the beach and felt the impossibility of counting the grains of sand. Scientists have tried to estimate this number, and a rough calculation for all the beaches and deserts on Earth comes to about 7 quintillion, 500 quadrillion grains. That's a 7.5 followed by 18 zeros, an astronomical number. But the universe just laughs at that. When we look at our own Milky Way galaxy, we estimate it contains somewhere between 100 billion and 400 billion stars. That's just our galaxy. For a long time, we thought our galaxy was the universe. Then, in the 1920s, Edwin Hubble proved that other nebulae were actually entire other galaxies, millions of light-years away. Using the Hubble Space Telescope, astronomers have estimated that in the observable universe, the part we can see, there are at least 2 trillion galaxies. So, let's do the math. Take the low-end estimate of 100 billion stars per galaxy and multiply it by 2 trillion galaxies. The result is 200 sextillion stars. That's a 2 followed by 23 zeros. Fact 5. A teaspoon of a neutron star weighs 6 billion tons. When a truly massive star, much larger than our Sun, reaches the end of its life, it explodes in a spectacular supernova. While the outer layers are blasted into space, the star's core collapses in on itself with incomprehensible force. If the star is big enough, it becomes a black hole. But if it's in a specific sweet spot, it becomes a neutron star. This collapse is so violent that it overcomes the forces that keep atoms separate. Protons and electrons are forcibly crushed together to form neutrons. The entire remaining mass of the star, perhaps 1.5 times the mass of our entire Sun, is packed into a sphere only about 20 kilometers, 12 miles across. Think about that. The mass of the Sun, packed into a space the size of a city. The result is the densest observable object in the universe, second only to black holes. The density is staggering. A single sugar cube-sized amount of neutron star material would weigh about 100 million tons. A single teaspoonful would weigh somewhere between 4 to 6 billion tons. That's the approximate weight of 900 Great Pyramids of Giza, Mount Everest, or the entire human population, crushed into an object you could hold in your hand, if you weren't, instantly vaporized and crushed by the gravity. Fact 6. Space has a distinct smell. This one sounds impossible, right? If space is a vacuum, how can it have a smell? Smell requires molecules to float into your nose. Well, astronauts have consistently reported a very peculiar, distinct odor upon returning from a spacewalk. When they get back into the airlock and remove their helmets, they report that their suits and equipment are coated in a strange scent. They can't smell it in space, but the smell clings to their gear. It's not just one thing, it's a complex cocktail. Many describe it as hot metal, like the smell of a welder's torch or welding fumes. Others have described it as seared steak or gunpowder. What is it? Scientists believe it's the smell of polycyclic aromatic hydrocarbons, PAHs. These are molecules that are abundant in the universe, often found in comet dust, meteorites, and cosmic dust. They are the byproducts of dying stars and chemical reactions floating through the void. When these particles, which are a form of space dust, cling to the astronauts' suits, they are brought into the airlock. Once repressurized with oxygen, they oxidize, releasing this sharp, burnt metallic odor. So, space itself doesn't have a smell, but the stuff in space absolutely does. Fact 7. It rains diamonds on Neptune and Uranus. We complain about rain here on Earth, but on the ice giant planets Neptune and Uranus, the weather forecast is extravagant. Scientists believe it literally rains solid diamonds. Here's how it works. The atmospheres of these distant, freezing giants are rich in methane, CH4. Deeper inside the planets, thousands of kilometers below the cloud tops, the pressure and temperature become immense. We're talking pressures hundreds of thousands of times greater than on Earth and temperatures reaching thousands of degrees Celsius. Under these extreme conditions, the methane molecules are shattered. The carbon, C, and hydrogen, H, atoms are ripped apart. The lighter hydrogen atoms likely float upwards, while the heavier carbon atoms are squeezed together by the incredible pressure. This immense pressure crystallizes the carbon, forming solid diamonds, just like they are formed deep within the Earth. These newly formed solid diamondbergs are denser than their surroundings, so they begin to fall, like precipitation. It is a slow, steady rain of diamonds sinking through the dense, slushy mantle of the planet over thousands of years. Scientists speculate that over the planet's long history, this diamond rain may have accumulated into a thick, solid layer of diamonds surrounding the planet's cores. Fact 8. The largest volcano in the solar system is on Mars. If you think the volcanoes in Hawaii or Iceland are impressive, let me introduce you to Olympus Mons on Mars. This thing isn't just a volcano, it's a monster. It is a shield volcano, similar in shape to the Hawaiian Islands, but its scale is almost fictional. Olympus Mons stands 21.9 kilometers, 13.6 miles, high. That is nearly 3 times the height of Mount Everest. Its base is so enormous that it would cover an area roughly the size of France or the state of Arizona. If you were to stand at the base of Olympus Mons, you wouldn't even be able to see the summit. The volcano is so wide, over 600 kilometers or 370 miles across, that its peak would be hidden far beyond the horizon. You would literally be climbing it without even realizing you were on a mountain. Why did it get so big? 2 main reasons. First, Mars has much lower surface gravity than Earth, only about 38% of ours. This allows mountains to build up much taller before they collapse under their own weight. Second, and more importantly, Mars does not have plate tectonics like Earth does. On Earth, a volcanic hotspot stays in one place, but the crustal plate moves over it, creating a chain of smaller islands like Hawaii. On Mars, the crust stayed put, and that hotspot just kept pouring out lava in the exact same location for hundreds of millions of years, building one single colossal monument. Fact 9. The largest known star would engulf Saturn. We think of our Sun as big. It contains 99.8% of all the mass in our solar system, and you could fit about 1.3 million Earths inside it. But in the grand scheme of the galaxy, our Sun is a fairly average, even modest-sized star. The title for the largest known star, by sheer volume, currently goes to a red hypergiant called UY Scuti. UY Scuti is located about 9,500 light-years away, and it is a spectacle of scale. Its estimated radius is about 1,800 times that of our Sun. Let's try to visualize this because the numbers are just silly. If you were to replace our Sun with UY Scuti, its surface would extend far past the orbit of Mercury. It would swallow Venus. It would swallow Earth. It would swallow Mars. It would even swallow the largest planet in our solar system, Jupiter. The edge of UY Scuti would reach all the way out past Jupiter's orbit, nearly to the orbit of Saturn. It's important to note the star is not very dense. It's incredibly puffed up and diffuse. It's in the final dying stages of its life, having swelled up enormously. It may only be 30 times more massive than our Sun, but its volume is 5 billion times greater. Fact 10. The speed of light is frustratingly slow. We call it the speed of light, and it's the universe's ultimate speed limit. 299,792,458 meters per second, or roughly 186,000 miles per second. In a single second, a beam of light can circle the Earth 7.5 times. It sounds incredibly fast, right? On a human scale, it is. But on a cosmic scale, the speed of light is painfully, agonizingly slow. It takes light from our sun about 8 minutes and 20 seconds to reach Earth. So, if the sun were to suddenly vanish, we wouldn't know about it for over 8 minutes. It takes that same light about 5.5 hours to reach Pluto. But let's go bigger. The closest star to us, Proxima Centauri, is 4.24 light-years away. That means the light we see from it tonight left that star 424 years ago. It's an old message. Want to cross our own Milky Way galaxy? That'll take you 100,000 years, even at light speed. Want to visit our nearest major galactic neighbor, the Andromeda Galaxy? Prepare for a 2.5 million-year journey. This speed limit is the primary reason interstellar travel is so difficult, and why communicating with any potential alien civilization would be a conversation that spans generations. The universe is big, and the speed of light makes it feel even bigger. Fact 11. Looking at the sky is looking into the past. This fact is a direct consequence of the last one. Because the speed of light is finite, nothing we see in the universe is live. We are always looking at the past. The further away an object is, the further back in time we are seeing it. When you look at the moon, you're seeing it as it was about 1.3 seconds ago. When you look at Jupiter, you might be seeing it as it was 40 minutes ago, depending on its orbit. But when you look at the stars, you are seeing history. That bright star Sirius, you're seeing 8.6-year-old light. The star Betelgeuse, the red shoulder of Orion, that light is from 640 years ago. When that light left the star, the Ming Dynasty was just beginning in China, and Joan of Arc hadn't been born yet. And then there are the galaxies. When you see the Andromeda Galaxy, which is visible to the naked eye in a very dark sky, you are seeing light that is 2.5 million years old. When that light began its journey, Homo sapiens didn't even exist. Our early ancestors, like Australopithecus, were still roaming Africa. And when telescopes like the Hubble or James Webb look at the most distant galaxies, they are seeing light that has traveled for over 13 billion years, giving us a baby picture of a universe that was only a few 100 million years old. Astronomy isn't just the study of space, it's the study of time. Fact 12. The universe is expanding and accelerating. In the 1920s, Edwin Hubble, yes, him again, made a landmark discovery. He observed that almost every galaxy he could see was moving away from us. More than that, he found that the further away a galaxy was, the faster it was moving away. This was the first concrete evidence that the universe itself is expanding. It's not that the galaxies are flying through space, but that space itself, the very fabric of reality, is stretching, carrying the galaxies along for the ride. For decades, astronomers assumed this expansion must be slowing down. Gravity, the attractive force of all the matter in the universe, should be acting like a brake, pulling everything back together. It was just a question of whether it would slow down and stop, or slow down and eventually collapse in a big crunch. Then, in 1998, two separate teams of astronomers made a discovery that won them the Nobel Prize and turned cosmology on its head. By observing distant supernovae, they found that not only is the expansion not slowing down, it's speeding up. The universe is accelerating its own expansion, pushing galaxies apart faster and faster. This was a complete shock. Something must be overpowering gravity on the largest scales, and that something has been given a name, even if we have no idea what it is. Fact 13. 85% of all matter is missing. If you take the best astronomical observations we have and add up everything we can see, planets, stars, gas clouds, galaxies, all of it, you run into a massive problem. It's not enough. The amount of gravity we observe in the universe is far, far greater than what all this visible stuff can account for. A prime example is the rotation of galaxies. Galaxies spin. The stars on the outer edges should, according to our laws of gravity, be moving much slower than the stars near the center, just as Pluto moves slower than Mercury. But they don't. Stars on the outer edges of galaxies are moving just as fast as the inner stars, which means they should be flung off into the void. They aren't. The only way they can stay in orbit is if there is a massive, invisible halo of something holding them together with its gravity. This invisible, mysterious substance is called dark matter. We call it dark simply because it does not interact with light. It doesn't emit, reflect, or absorb light, which is why we can't see it. We only know it's there because we can see its gravitational pull on everything else. Based on our calculations, all the normal matter we know and love, the stuff that makes you, me, and the stars, accounts for only 15% of the total matter in the universe. The other 85% is this invisible, unknown dark matter. Fact 14. Dark energy makes up 70% of the universe. So, we just established that 85% of all matter is dark matter. But the rabbit hole goes deeper. If we look at the total energy density budget of the entire cosmos, everything, not just matter, the picture gets even stranger. Remember fact 12, that the universe's expansion is accelerating? Something has to be pushing it, acting as an anti-gravity force. This mysterious repulsive force is what we call dark energy. It appears to be a property of vacuum itself. The more empty space there is, the more of this push there is. And as the universe expands, it creates more space, which in turn creates more dark energy, which causes it to expand even faster. When scientists calculated how much of this stuff would be needed to account for the observed acceleration, the number was enormous. It turns out that dark energy makes up roughly 68% to 70% of the entire universe. Dark matter, the invisible stuff holding galaxies together, makes up about 25% to 27%. And the normal matter, the atoms that make up every star, every planet, and every human, that's less than 5%. We have spent our entire history studying the 5% of the universe we can see, while 95% of it, dark matter and dark energy, remains a complete and utter mystery. Fact 15. We are being pulled by the Great Attractor. Something big is out there, and it's pulling us. For decades, astronomers have noticed a strange anomaly in our little corner of the universe. Our Milky Way galaxy, our neighbor Andromeda, and the entire cluster of galaxies we belong to, the Virgo supercluster, are all being yanked through space at a staggering 2.2 million kilometers per hour. We are all hurtling towards a specific, empty-looking patch of sky in the direction of the constellation Centaurus. This isn't the normal expansion of the universe. This is a separate, peculiar velocity. It's as if we are on a river, the expansion, but are also being pulled by a massive, unseen current. This current is the gravitational pull of an object or region of such immense mass that it's literally pulling in hundreds of thousands of galaxies. It has been nicknamed the Great Attractor. The problem? We can't see it very well. It's located in a region of the sky called the zone of avoidance, a patch of sky that is completely obscured by the bright, dense, dusty disk of our own Milky Way galaxy. We are trying to look at something massive through the thickest, dirtiest part of our own cosmic window. While we've identified a massive supercluster of galaxies, the Laniakea supercluster, in that direction, which we are a part of, the full extent and nature of the Great Attractor remains one of the universe's great gravitational mysteries. Fact 16. There are rogue planets without stars. We are used to the idea of a solar system, planets dutifully orbiting a parent star, but the universe is a chaotic place, especially during the formation of solar systems. Gravity is a messy game of billiards. As planets form and migrate, their gravitational interactions can be violent. Sometimes a planet can be kicked out of its home system, ejected by the gravity of a larger sibling planet, like a Jupiter or a passing star. These kicked-out planets become rogue planets, or orphans. They are untethered, doomed to wander the cold, dark void of interstellar space forever, not orbiting any star. How many are there? We don't know because they are incredibly hard to find. They don't produce their own light, and there's no parent star to illuminate them. We can only find them through gravitational microlensing, where a rogue planet passes in front of a distant star, and its gravity briefly bends and magnifies the star's light. Based on the few we've found, scientists now estimate that there could be billions, perhaps even trillions, of these orphan planets in our galaxy alone. Some estimates suggest they might outnumber the stars. Our galaxy could be teeming with dark, cold worlds adrift in the endless night. Fact 17. The Buddha's void is the great nothing. If you thought space was empty, you haven't met the Botas, pronounced Bo-O-Ts, void. On the largest scales, the universe has a structure. Galaxies are not spread out randomly. They are clumped together in long, interconnected filaments and superclusters separated by vast, relatively empty regions called voids. This cosmic structure is often called the cosmic web. The boat's void is the king of these voids. It is a supervoid, an incomprehensibly large, spherical region of space that is almost entirely empty. It was discovered in 1981, and it shocked astronomers. How big is it? The Buddha's void is approximately 330 million light-years in diameter. If our Milky Way galaxy were at its center, we wouldn't have even known other galaxies existed until the 1960s. That's how vast and empty it is. It's not a perfect vacuum. When it was first discovered, scientists could only find 8 galaxies inside it. Further study has since located about 60. But in a region of space that should contain well over 10,000 galaxies, it only has 60. This is the great nothing. It's a chilling reminder that while the universe is full of matter and light, it is also defined by staggering, unimaginable emptiness. Fact 18. There is a giant cloud of alcohol in space. If you're looking for the universe's biggest party, head towards the constellation Aquila. Deep in interstellar space, in a vast star-forming region called Sagittarius B2, astronomers have discovered a gigantic, swirling cloud of molecules. This cloud is massive, spanning 150 light-years across. That's thousands of times larger than our solar system. And it contains a truly staggering amount of alcohol. Specifically, it's loaded with vinyl alcohol and methanol. But the real kicker is that it also contains vast quantities of ethyl format. This chemical is interesting for 2 reasons. First, it's a precursor to amino acids, a building block of life. Second, ethyl formate is the compound responsible for the distinct flavor of raspberries and the smell of rum. No, you can't drink it. It's mixed with other, less tasty chemicals like carbon monoxide and hydrogen cyanide. But the cloud contains billions of liters of this stuff. It's floating. Molecular evidence that the complex organic chemistry needed for life is not unique to Earth. It's being cooked up in the kitchens of star-forming regions all across the galaxy, which is a very exciting thought for the search for life elsewhere. Fact 19. We have recorded the sound of a black hole. This sounds like a contradiction of fact number 1. Space is silent. And it is. Mostly. Sound, as we know it, can't travel through a vacuum. But sound can travel through a medium, and the space between galaxies in a galaxy cluster is not a perfect vacuum. It is filled with an incredibly hot, thin, diffuse gas called plasma. In 2003, astronomers using NASA's Chandra X-ray Observatory studied the Perseus galaxy cluster, a massive collection of galaxies 250 million light-years away. At its center is a supermassive black hole. They discovered that this black hole wasn't just sitting there. It was active, sending out ripples or pressure waves into the surrounding cluster gas. These ripples were, in essence, sound waves. The problem? These sound waves are at a frequency we can't hear. The central note is a B-flat, but it's about 57 octaves below middle C. Its period is 1 ripple every 10 million years. This is a sound so low it's completely inaudible. However, NASA scientists were able to sonify this data. They scaled the sound waves up by 57 and 58 octaves, translating the astronomical data into a range humans can hear. The result, which you can find online, is a low, eerie, haunting moan. It is the real, translated sound of one of the most powerful objects in the universe. Fact 20. The universe is bigger than we can see. This is a fundamental concept that twists the mind. We've talked about the observable universe, which is about 93 billion light-years across. This is the part of the universe whose light has had time to reach us since the Big Bang, which was 13.8 billion years ago. But what's beyond that? What's outside the observable part? The honest answer is, we don't know, but it's almost certainly more universe. The universe is expanding, and the light from galaxies beyond that, 13.8 billion light-year boundary, known as the cosmic light horizon, is being carried away from us by the expansion of space faster than the light can travel towards us. We are in a bubble of observation, and we can never, ever see anything outside of it. That light will never reach us. How big is the whole universe? According to theories based on cosmic inflation, the total size of the universe is at least 250 times larger than the part we can see. Other theories suggest it might be functionally infinite. We are likely just one tiny, visible patch in a cosmic ocean that is so vast, our 93 billion light-year observable bubble is, by comparison, the size of a single atom. And that is perhaps the most humbling fact of all. The video continues. The host is re-energized. All right, explorers, welcome back. You survived the first 20 facts, from silent space to diamond rain and the mind-bending reality of dark energy. I hope you had a chance to let your brain reset, because we are just getting warmed up. The universe is a bottomless treasure chest of what? Moments, and we are diving back in for another 20. Let's pick up right where we left off. Fact 21. The coldest place in the universe is man-made. We often think of space as the ultimate cold. The background temperature of the cosmos, the leftover heat from the Big Bang known as the cosmic microwave background, is a chilly 2.7 Kelvin. That's 270.45 degrees Celsius, 454.29 degrees Fahrenheit, just a couple of degrees above absolute zero, the theoretical point where all molecular motion stops. You'd think the coldest natural place would be the deepest, darkest void. For a long time, the title went to the Boomerang Nebula, a young planetary nebula 5,000 light-years away. Gas is expanding from its dying central star so rapidly that it has cooled itself to just 1 Kelvin. But the universe, it turns out, was beaten by its own creation, us. The coldest known place in the entire universe is not in a distant nebula, but in a laboratory, right here on Earth, in places like the Cold Atom Laboratory on the International Space Station or in labs at MIT and other research institutions. Scientists can use lasers and magnetic fields to trap and cool atoms. They slow them down until they are practically motionless, achieving temperatures measured in nanokelvins or billionths of a degree above absolute zero. At these insane temperatures, matter stops behaving like normal. It enters a bizarre quantum state called a Bose-Einstein condensate. It's official. Humanity has out-chilled the universe. Fact 22. The moon is slowly drifting away from Earth. Our moon, the beautiful constant presence in our night sky that controls our tides, is a fair-weather friend. It is slowly, but measurably, abandoning us. This is all thanks to a process called tidal acceleration. It works like this. The moon's gravity pulls on Earth's oceans, creating the tides. As the Earth rotates, much faster than the moon orbits, it effectively drags this tidal bulge of water slightly ahead of the moon. This bulge of water, which has its own mass and gravity, then pulls back on the moon, like a gravitational leash pulling it forward in its orbit. This constant tug gives the moon a small boost of energy, pushing it into a slightly higher, wider orbit. The result? The moon is drifting away from the Earth at a rate of about 3.8 centimeters, 1.5 inches per year. That's about the same speed your fingernails grow. It doesn't sound like much, but over geological time it adds up. Billions of years ago, the moon was much closer, appearing enormous in the sky, and a day on Earth was only about 18 hours long. As the moon drifts away, Earth's rotation slows down. Our days get longer to conserve angular momentum. Don't worry, it won't escape entirely. But billions of years from now, it will be a much smaller, more distant companion in the sky. Fact 24. A single solar flare can release the energy of 1 billion atomic bombs. We tend to think of our sun as a stable, life-giving ball of light. And it is. But it's also a raging 15 million degree nuclear furnace that has some serious mood swings. The sun's magnetic field is an incredibly complex, tangled mess. Sometimes these magnetic field lines get twisted up like rubber bands, building up enormous tension. When they suddenly snap and realign, they release a truly mind-boggling amount of energy in an event called a solar flare. A large solar flare can release the equivalent energy of billions of 1 megaton nuclear bombs exploding all at once. These flares are often accompanied by a coronal mass ejection, CME, which is a space hurricane of charged particles, a chunk of the sun's own atmosphere, weighing billions of tons and traveling at millions of miles per hour. When one of these is aimed at Earth, we are mostly protected by our planet's magnetic field. But a direct hit from a super flare could be catastrophic. The most famous was the 1859 Carrington event, which was so powerful it set telegraph offices on fire and created auroras so bright people could read newspapers by their light in the middle of the night. If an event that strong hit us today, it could wipe out satellite grids, GPS, and power grids worldwide, plunging us into a technological dark age. Fact 25. We are all made of stardust. This isn't just a poetic phrase. It is a literal, scientific fact. The universe didn't start with all the ingredients for life. The Big Bang, 13.8 billion years ago, produced almost exclusively hydrogen and helium, the two simplest, lightest elements. That was it. So where did everything else come from? Where did the carbon in your DNA, the calcium in your bones, the iron in your blood, and the oxygen you are breathing right now come from? It was all forged, cooked, and created inside the incredibly hot, high-pressure cores of stars. Stars are element factories. Through nuclear fusion, they spend their entire lives smashing lighter elements together to create heavier ones. Hydrogen to helium, helium to carbon, carbon to oxygen, and so on, all the way up to iron. When those stars, especially the massive ones, reach the end of their lives, they explode in a supernova. That explosion is the only event energetic enough to create even heavier elements, like gold and uranium, and, crucially, to blast all those newly formed elements out into the galaxy. This stardust then mixes with interstellar gas clouds which eventually collapse to form new solar systems, new planets, and, eventually, new life. You are not just on the Earth. You are the Earth. You are the universe, having become self-aware. Fact 26. A day on Mercury is 176 Earth days long. We already established that Venus is a rotational freak show, but Mercury has its own bizarre claim to fame in the weirdest day competition. A year on Mercury, one full orbit around the Sun, is super fast. It zips around in just 88 Earth days. Because of this, you might assume its day is also short. You'd be very wrong. Mercury is tidally locked to the Sun, but in a strange way. It's not a one-to-one lock like our Moon. Instead, it has a 3.2 spin-orbit resonance. This means for every 3 times it rotates on its axis, it orbits the Sun twice. So, a sidereal day, one full rotation on Mercury, is 59 Earth days long. But we don't experience a day as one rotation. We experience it as one solar day, the time from one sunrise to the next. And this is where it gets crazy. Because Mercury is rotating so slowly while it's also speeding around the Sun, it takes 176 Earth days for the Sun to appear in the same spot in the sky. This means Mercury's solar day, 176 days, is twice as long as its entire year, 88 days. If you lived on Mercury, you would have to wait 2 full years just to experience one sunrise to sunrise day. It's a place where the birthdays come twice as fast as the mornings. Fact 27. Jupiter is a cosmic vacuum cleaner. We owe a deep debt of gratitude to Jupiter. It is, by far, the most massive planet in our solar system, more than twice as massive as all the other planets, moons, asteroids, and comets combined. It is a king, and its gravity rules the solar system. This immense gravity acts as a gravitational shield, or a cosmic vacuum cleaner. Our solar system is full of debris, especially comets and asteroids, many of which are in unstable orbits that could one day send them on a collision course with Earth. Jupiter, in its orbit, acts as a bouncer. Its gravity is so powerful that it either flings these dangerous objects out of the solar system entirely, or, more often, pulls them in to collide with itself. We have direct evidence of this. In 1994, astronomers around the world watched in awe as the comet Shoemaker-Levy 9, which had been captured and torn apart by Jupiter's gravity, slammed into the planet in a series of 21 fragments. The impact scars were larger than the entire planet Earth. Without Jupiter clearing the cosmic shooting gallery for the last 4.5 billion years, Earth would have suffered far more catastrophic impacts, and complex life like us might never have had the stable environment needed to evolve. Fact 28. Saturn's rings are 99% ice, and they are disappearing. Saturn's rings are arguably the most beautiful feature in our solar system. They look solid and majestic from a distance, but they are not. They are an enormous, incredibly thin disk made of countless billions of individual particles of water ice. These particles range in size from tiny specks of dust to chunks as large as a house. The entire ring system is vast, stretching up to 282,000 kilometers, 175,000 miles, wide, but it is, on average, only about 10 meters, 30 feet, thick. That's what makes them so remarkable. They are proportionally thinner than a sheet of paper. But this beauty is temporary. The rings are disappearing. They are caught in a delicate balance between Saturn's gravity pulling them in and their orbital velocity flinging them out. But they are constantly being bombarded by micrometeorites and radiation. This charges the ice particles, which are then grabbed by Saturn's magnetic field and rained down onto the planet's atmosphere. This ring rain is dumping tons of water onto Saturn every second. Based on observations from the Cassini spacecraft, scientists estimate that the rings, which are likely a recent addition to the solar system, will be completely gone in as little as 100 million years. In cosmic terms, we are lucky to be alive in the brief moment they exist. Fact 29. Uranus is tilted completely on its side. Every planet in our solar system spins on an axis, and that axis is usually more or less upright relative to its orbit around the Sun. Earth, for example, is tilted at 23.5 degrees, which is what gives us our seasons. Jupiter is tilted at 3 degrees, so it has almost no seasons at all. And then there's Uranus. Uranus is the weird uncle of the solar system. It has been knocked over completely. Its axis of rotation is tilted at a staggering 98 degrees. This means it doesn't spin like a top as it orbits. It rolls like a ball. The consequences of this are bizarre. A year on Uranus is 84 Earth years long. Because of its extreme tilt, this means that for 21 years, its north pole is pointed directly at the Sun, experiencing one continuous summer day. Then, as it orbits, the Sun sets, and for the next 21 years, that same pole is plunged into a continuous, freezing cold winter night. Its seasons are decades long. The prevailing theory is that billions of years ago, during its formation, a massive Earth-sized protoplanet slammed into Uranus and literally knocked it over for good. Fact 30. Triton, Neptune's moon, has ice volcanoes, and orbits backwards. Moons are supposed to orbit their planets in the same direction the planet is spinning. This is called a prograde orbit, and it's the standard because moons are typically formed from the same swirling disk of material as the planet itself. Not Triton. It is the largest of Neptune's moons, and it orbits backwards. This retrograde orbit is a dead giveaway that Triton is not a native moon. It is an imposter. The only way for this to happen is if Triton was once a dwarf planet, like Pluto, that formed in the Kuiper Belt, the icy debris field beyond Neptune. At some point it wandered too close to Neptune and was captured by the giant's gravity. This capture would have been a violent, chaotic event, and it imbued Triton with some strange properties. It is one of the most geologically active bodies in the solar system, despite being one of the coldest, a surface temperature of 235 Bate-de-Krukakihiru, 391 Duhmiruin. NASA's Voyager 2 spacecraft flew by and photographed active cryovolcanoes, or ice volcanoes. But instead of spewing molten rock, these volcanoes erupt plumes of nitrogen gas and dark, icy materials, which then freeze and fall back to the surface as nitrogen snow. It's a captured, backward, frozen, volcanic world. Fact 31. There is a planet of burning ice. Physics can get really weird under extreme conditions, and the exoplanet Gliese 436b is a prime example. This is a Neptune-sized planet orbiting a red dwarf star about 33 light-years away. It orbits its star extremely closely, completing a year in just 2.6 Earth days. Because it's so close to its star, its surface temperature is a roasting 439 degrees Celsius, 822 degrees. Based on its size and mass, we know the planet is largely composed of water. And here is the paradox. The planet is covered in ice. How can ice exist at 439 degrees Celsius, a temperature hot enough to melt lead? The answer is pressure. The planet's gravity is so immense, and it has such a thick, crushing atmosphere, that the water molecules are squeezed together with unbelievable force. This pressure is so strong that it overpowers the heat. The water molecules are locked into a solid lattice, a state of matter called ice X, ice 10. They simply cannot evaporate into gas no matter how hot they get. So, Gliese 436b remains a solid ball of burning ice, a state of matter that is completely alien to our everyday experience. Fact 32. The Milky Way and Andromeda galaxies will collide. Our galaxy, the Milky Way, is on a collision course. Our nearest major galactic neighbor, the Andromeda galaxy, M31, is currently 2.5 million light-years away. But it's not staying there. Thanks to the relentless pull of gravity, Andromeda and the Milky Way are hurtling towards each other at a blistering speed of 110 kilometers per second, or about 250,000 miles per hour. Mark your calendars. This cosmic crash is scheduled to begin in about 4.5 billion years. What will this look like? It won't be a collision in the way you think, with stars crashing into each other. Space is so vast that the individual stars will almost all pass by each other like ghosts in the night. Instead, it will be a gravitational merger. The two massive spiral galaxies will warp, distort, and tear each other apart with their tidal forces. They will dance around each other for hundreds of millions of years, throwing out enormous streamers of stars and gas, before finally settling down and merging into one, single, gigantic elliptical galaxy. Our solar system will almost certainly survive, but our descendants, if any exist, will look up at a night sky that is completely, spectacularly different, dominated by the fiery, star-forming chaos of the merger, which some astronomers have nicknamed Milkomeda. Fact 33. Black holes aren't cosmic vacuum cleaners. Let's bust a common myth. Black holes are not cosmic vacuum cleaners that suck up everything in the universe. If you were to take our sun and magically replace it with a black hole of the exact same mass, what would happen to Earth? The answer is absolutely nothing. Well, okay, it would get very dark and very cold, and we'd all die. But gravitationally, nothing would change. The Earth would continue to orbit that black hole in the exact same path it orbits the Sun right now. A black hole is just an object with gravity, like anything else. Its gravity is only extreme when you get very, very close to it. The defining feature of a black hole is not that it sucks, but that it is incredibly dense. It has packed so much mass into such a tiny space that its escape velocity, The speed you need to escape its gravity becomes faster than the speed of light. This point of no return is called the event horizon. If you are outside the event horizon, you can orbit a black hole just fine. The second you cross that boundary, you are trapped, because nothing can travel faster than light. So, a black hole doesn't hunt, it just waits. Fact 34. Black holes can evaporate. We just learned that nothing, not even light, can escape a black hole once it crosses the event horizon. That was the consensus for decades, until Stephen Hawking came along. In 1974, Hawking proposed a groundbreaking theory that combined quantum mechanics with general relativity. In the empty vacuum of space, virtual particles are constantly popping into existence, a particle and an antiparticle pair. They exist for a fraction of a second before they annihilate each other and disappear. Hawking realized that if this happens right on the edge of a black hole's event horizon, one particle might fall in while the other escapes. The particle that escapes can't be free. It has to get its energy from somewhere. It borrows it from the black hole's own mass. The escaping particle becomes a real particle, and the black hole loses an infinitesimal amount of mass. This process is called Hawking radiation. Over unimaginable timescales, trillions upon trillions of years, and far longer for larger black holes, this slow leak of energy will cause the black hole to lose mass, shrink, and, in a final flash of gamma rays, evaporate completely. So, it turns out, black holes aren't forever after all. Fact 35. The largest known black hole is a ultramassive monster. We have a supermassive black hole at the center of our galaxy, Sagittarius A star. It's a beast, with a mass of about 4 million times that of our Sun. But in the cosmic zoo, that's a small fry. Let's talk about the really big ones. Astronomers have found ultramassive black holes. The current confirmed champion is a black hole at the center of a quasar called TON 618. Or TON 618. A quasar is an active galactic nucleus. Where a supermassive black hole is actively feeding on so much gas and dust that the accretion disk of infalling material shines brighter than its entire host galaxy. The black hole powering TON 618 it's a number that doesn't make sense. It is estimated to have a mass of 66 billion times the mass of our Sun. It is so large that its event horizon, the shadow of the black hole, would be over 1/300 astronomical units, AU, wide. 1 AU is the distance from the Earth to the Sun. Pluto is 40 AU away. This single black hole's shadow is large enough to swallow our entire solar system 30 times over. It is a true monster, a gravitational singularity on a scale that defies all human comparison. Fact 36. Time passes slower in strong gravity. This isn't science fiction. It's a core principle of Einstein's theory of general relativity. Gravity is not a force, it is a warping or curving of spacetime itself. Massive objects bend spacetime, and the more massive the object, the steeper the curve. What we experience as time is also affected by this curvature. The stronger the gravity, the more spacetime is warped, and the slower time itself flows for an observer in that gravity well. This is called gravitational time dilation, and it's not just a theory. It's a real, measurable effect. The GPS satellites in orbit around the Earth are in a weaker gravity field than we are on the surface. Because of this, their internal clocks run faster than our clocks on the ground, by about 45 microseconds per day. If the GPS system didn't actively correct for this relativistic effect, your GPS navigation would be off by several miles within a single day. The effect is extreme near a black hole. An observer watching you fall into a black hole would see your clock tick slower and slower, eventually appearing to freeze at the event horizon. You, however, would feel your own time passing normally as you cross the boundary to your doom. Fact 37. The universe has an average color. If you could take all the light from all the stars, all the galaxies, and all the glowing gas clouds, put it in a giant cosmic paint bucket and mix it all together, what average color would you get? In 2002, a team of astronomers from Johns Hopkins University did just that. They took a cosmic census by analyzing the light from over 200,000 galaxies. They combined the spectral fingerprints of all this light to create an average. The result? The average color of the universe is a very pale, beige-ish white. They officially named it cosmic latte. Other names considered included univague and cappuccino cosmico. This color tells a story. When the universe was younger, it would have been more blue, as it was dominated by massive, young, hot, blue-burning stars. But as the universe has aged, more and more stars have become older, redder stars, like red dwarfs and red giants. This reddening of the universe's light has shifted the average color from blue to its current, mellow beige. It is, quite literally, the color of an aging cosmos. Fact 38. The Fermi Paradox. Where is everybody? Our galaxy, the Milky Way, contains between 100 and 400 billion stars. We now know that most of those stars have planets. A significant fraction of those planets are likely Earth-like and exist in the habitable zone, where liquid water can exist. Given these numbers, there should be millions or even billions of worlds in our galaxy alone that could support life. Our galaxy is 13.6 billion years old, and Earth is only 4.5 billion years old. There has been ample time for other civilizations to evolve, develop, and become interstellar. Even at slow, sublight speed travel, a civilization could colonize the entire galaxy in just a few million years, a cosmic blink of an eye. So, as the physicist Enrico Fermi famously asked his colleagues at lunch one day, "Where is everybody?" This is the Fermi Paradox. The numbers say the sky should be crawling with technological civilizations, radio signals, and starfaring empires. Yet we see nothing. No signals, no ships, no evidence. Is life incredibly rare? Does intelligence inevitably destroy itself? Are they hiding? Or are we just the first? It is one of the most profound and unsettling questions in all of science. Fact 39. We have heard black holes collide. For 100 years, one of the biggest predictions of Einstein's general relativity was unproven: gravitational waves. Einstein predicted that when massive objects accelerate, they should create ripples in the fabric of spacetime itself, just like throwing a bowling ball into a trampoline would create vibrations. These ripples, traveling at the speed of light, would alternately stretch and compress spacetime as they passed. The problem is, these ripples are unbelievably tiny. For a century, we had no instrument sensitive enough to detect them. That changed on September 14, 2015. The two detectors of the LIGO, Laser Interferometer, Gravitational Wave Observatory, simultaneously registered a chirp. It was a signal that precisely matched the computer-modeled waveform of two massive black holes, 29 and 36, times the Sun's mass, spiraling into each other and merging in a galaxy 1.3 billion light-years away. For the first time, we didn't just see the universe. We listened to it. We heard the sound of space-time itself ringing like a bell from one of the most violent events in the cosmos. This discovery won the Nobel Prize and opened an entirely new sense for us to explore the universe, allowing us to detect things like colliding black holes that are completely invisible. Fact 40. The largest known thing in the universe. What is the biggest single thing in the universe? It's not a star or a black hole or a galaxy. It's not even a supercluster of galaxies. The largest known coherent structure in the cosmos is the Hercules Corona Borealis Great Wall. This wall is a galaxy filament, a part of the cosmic web we talked about earlier. But its scale is an affront to our understanding of the universe. It is a colossal sheet of galaxies, gravitationally bound together. How big is it? It is 10 billion light-years across. Let that sink in. The entire observable universe is 93 billion light-years across. This single structure is more than 10% the size of everything we can see. Its existence is a major problem for cosmology. Our current models suggest that the universe shouldn't have been able to form a structure that big in just 13.8 billion years. The forces of gravity and expansion shouldn't allow for something so gravitationally connected and so enormous. It's so big that it breaks our models. It is a thing that, according to our theories, shouldn't exist. And yet, it's there. The video begins. The host is animated and leaning toward the camera. Hello again, cosmic explorers, and welcome back to NK Fantastic. We are officially past the halfway point of our 80-fact marathon. You've survived dark matter, evaporating black holes, and planets made of burning ice. If your brain hasn't completely melted yet, then you are a true adventurer, and you've come to the right place. The universe, it turns in, keeps its weirdest stuff hidden a little deeper. We've still got 40 facts to go, and the questions are only getting bigger. Are you ready to dive back in? Let's get to the next 20. Fact 41. Neutron stars can spin 600 times per second. We talked about neutron stars, the city-sized, hyperdense corpses of giant stars. But we left out their most astonishing party trick: their spin. This is all thanks to the conservation of angular momentum. It's the same principle an ice skater uses. When they pull their arms in, they spin faster. Now, imagine a star many times larger than our Sun collapsing down into a sphere just 20 kilometers across. That is the most extreme pulling in your arms in the universe. The result is a pulsar. These neutron stars spin at unbelievable speeds. We found many that spin dozens of times per second. The fastest one ever recorded, named PSR J1748-2446 AD, rotates 716 times every single second. That's 716 days in 1 second. The equator of this city-sized object is moving at 24% the speed of light. They are so incredibly precise that they are the universe's most accurate clocks, and as they spin, they sweep beams of radiation across the cosmos like a terrifying cosmic lighthouse. Fact 42. We detected a wow signal from space. Once. On August 15, 1977, astronomer Jerry Amon was working at the Big Ear radio telescope in Ohio, which was scanning the skies as part of the SETI project, the search for extraterrestrial intelligence. The telescope was listening for any non-natural signals. That night, the telescope picked up a signal that was impossible. It was a powerful, narrow-band radio signal lasting for 72 seconds. That perfectly matched the profile of what you'd expect an alien broadcast to look like. It was 30 times stronger than the background radiation of space. Amon was so shocked by the data printout that he grabbed a red pen, circled the corresponding alphanumeric code, 6EQUJ5, and wrote the only word that came to mind: wow. The signal came from the direction of the constellation Sagittarius. We have pointed our telescopes back at that exact patch of sky thousands of times since 1977, and we have heard nothing. It has never, ever been repeated. We have no natural explanation for it. It remains the single most tantalizing, mysterious, and unexplainable candidate for an extraterrestrial signal ever detected. Fact 43. Jupiter's Great Red Spot is shrinking. Jupiter's most famous feature is the Great Red Spot, a colossal, raging anticyclone, a storm that has been observed for at least 190 years, and possibly for over 350. It is a storm so vast that, for most of human history, you could comfortably fit 3 entire planet Earths inside it. But this iconic landmark is dying. When the Voyager probes flew by in 1979, it was already smaller than its historical size, and in the decades since, astronomers have watched it shrink dramatically. Today, the Great Red Spot is only large enough to fit one Earth. It seems to be getting squeezed by other jet streams in Jupiter's atmosphere. As it shrinks in width, it also seems to be growing vertically, getting taller, like a clay pot being spun on a wheel. We are watching, in real time, the death of the most powerful storm in the solar system. We have no idea how much longer it will last. It could be gone in 20 years, or it could stabilize and rage for another century. It's a powerful reminder that the solar system is not a static museum. It's a dynamic, changing place. Fact 44. White holes are the theoretical opposite of black holes. You know all about black holes. Gravity so strong that nothing, not even light, can escape. But what if the math worked in reverse? Within Einstein's equations of general relativity, there exists a perfect theoretical opposite: a white hole. A white hole is a region of spacetime that you cannot enter from the outside. Instead, it is a source that erupts, constantly and violently spitting out matter and light. While a black hole is a one-way entrance, a white hole is a one-way exit. Think of it as a cosmic no-entry sign. What would it look like? It would be an object of pure, blinding, catastrophic brightness, but you could never, ever reach it. Any object you threw at it would never cross its event horizon. Do they exist? We have absolutely zero evidence for them. They are purely mathematical ghosts. Some physicists have theorized that the Big Bang itself may have been a white hole, the ultimate spitting-out event. Others wonder if they could be the exit for a wormhole connected to a black hole. For now, they remain one of physics' most fascinating what-ifs. Fact 45. Our sun is actually white, not yellow. This fact breaks a lifetime of common sense. Every drawing you made as a child, every emoji, every picture of the sun shows it as a bright, happy yellow or orange ball. But it's not. The color of a star is determined by its temperature. The sun, with a surface temperature of 5500 Celsius, actually emits its peak light in the green part of the spectrum. But it also emits enormous amounts of light in all the other colors: red, orange, yellow, blue, and violet. When your eye receives all of those colors at once, in equal proportion, your brain interprets that combination as pure white. So, why does it look yellow to us? You're not looking at the sun. You're looking at the sun through Earth's atmosphere. The atmosphere is excellent at scattering blue and violet light. This scattering is what makes the sky blue. By scattering the blue light out of the direct beam, the remaining light that hits your eye looks yellowish. At sunset, the sun's light passes through even more atmosphere, scattering even more blue and green, leaving only the deep reds and oranges. If you were an astronaut in space, you would see the sun for what it truly is: a terrifyingly brilliant white-hot star. Fact 46. The dark side of the moon is a myth. Everyone has heard the phrase, the dark side of the moon. It evokes mystery and a land of permanent night. The only problem is, it doesn't exist. The myth comes from a misunderstanding of tidal locking. The moon is tidally locked to Earth, which means it rotates on its axis at the exact same speed that it orbits the Earth. The result is that we only ever see one face, which we call the near side. The other face, which we never see from Earth, is not the dark side, it's the far side. The moon is rotating, just like Earth. As it orbits, the far side gets just as much sunlight as the near side. It has a day and night that both last about 14 Earth days. When we have a new moon, when the moon is dark to us, the far side is fully illuminated, experiencing its full moon. The only time the far side is actually dark is during its new moon, which is when we see a full moon. So, the far side of the moon is fully lit. It's just not aimed at us. Fact 47. The universe is almost perfectly flat. This doesn't mean the universe is a 2D pancake. In cosmology, flat describes the geometry of spacetime on the largest possible scales. There are three possibilities. It could be positively curved, like a sphere, negatively curved, like a saddle, or flat, like a sheet of paper. If the universe were spherical, two parallel beams of light would eventually converge. If it were saddle-shaped, they would diverge. If it's flat, they will stay parallel forever. This is something we can actually measure. By studying the hot and cold spots in the cosmic microwave background, the baby picture of the universe, scientists can measure the geometry, and the results are conclusive. The universe is shockingly flat. Its curvature is so close to zero that it's statistically indistinguishable from perfect flatness. This has a massive implication. A flat universe is a universe that is most likely infinite. If it's flat, it doesn't curve back on itself. This means the 93 billion light-year observable universe is just our tiny bubble in a potentially endless sea of space, time, and other galaxies. Fact 48. The oldest, farthest galaxy we've seen. Challenges our theories. Thanks to the James Webb Space Telescope, JWST, we are in a golden age of cosmic archaeology. We are peering back to the cosmic dawn, the period just a few hundred million years after the Big Bang. In 2022, JWST spotted a galaxy called JADES GS Z13-0. This isn't just a smudge. It's a small but well-formed galaxy. The light we are seeing from it is 13.4 billion years old, meaning we are seeing it as it existed just 325 million years after the universe began. This galaxy shouldn't exist. According to our old models, that is not nearly enough time for gravity to pull together enough gas and dust to form a bright, structured galaxy like this one. JADES, and several others like it, are too big, too bright, and too early. This is a wonderful crisis. It means our understanding of how the first stars and galaxies formed is incomplete. The universe, it seems, got a head start and was building complex structures far faster than we ever thought possible. Fact 49. The three likely ends of the universe. How does it all end? While we don't know for sure, cosmological theories point to three main possibilities. First is the Big Freeze, or heat death. This is the most likely scenario. Thanks to dark energy, the universe's expansion accelerates. Galaxies are pushed so far apart they disappear from each other's view. Stars burn out one by one. Matter decays. The universe becomes a cold, dark, empty void of diffuse particles, approaching absolute zero, where nothing ever happens again. Forever. Second is the Big Rip. In this scenario, dark energy is even more powerful than we thought. It becomes so strong that it not only pushes galaxies apart, but it eventually overcomes gravity itself. It will tear galaxies apart, then solar systems, then it will rip apart stars and planets. In the final, terrifying moments, dark energy would become so strong it would overcome the forces holding atoms together, and the very fabric of reality would be ripped to shreds. Third is the Big Crunch. This was the favorite theory before dark energy was discovered. If gravity is strong enough, it could one day stop the expansion and reverse it. The universe would begin to collapse in on itself, with all galaxies rushing towards each other, culminating in a final, fiery singularity, perhaps recycling itself into a new Big Bang. Fact 50. The tallest cliff in the solar system is on a moon of Uranus. The tallest volcano is Olympus Mons. But the tallest, sheerest cliff? For that, you have to travel to Miranda, a tiny, strange moon of Uranus. Miranda looks like it was smashed to pieces and then haphazardly glued back together with canyons and bizarre chevron features. Its most terrifying feature is Verona Rupes. It is a fault scarp, a cliff, that is estimated to be 20 kilometers, 12 miles deep. That is 10 times deeper than the Grand Canyon. Because Miranda is such a tiny, low-gravity world, falling off this cliff would be a unique experience. If you were an astronaut who stepped off the edge, it would take you 12 full minutes to reach the bottom. You would have plenty of time to ponder your decisions, listen to an entire song, and enjoy the view. You wouldn't just splat, either. Despite the long fall, you'd impact the ground at about 200 kilometers per hour, 125 kilometers. Fact 51. We have landed on a moon in the outer solar system. We've landed on our moon many times. We've landed rovers on Mars, but that's the inner solar system. The outer solar system, the realm of the gas giants, is 1 billion miles away. And we have successfully landed there just once. On January 14, 2005, the Huygens probe, part of the Cassini mission, detached, entered the atmosphere of Saturn's largest moon, Titan, and parachuted down to its surface. This is the farthest landing from Earth in human history. What it found was an alien paradise. Titan is a world shrouded in a thick, orange, nitrogen-rich atmosphere. It is so cold, 129 through 290, that water ice is as hard as granite. But on its surface, Huygens landed in what looked like a damp riverbed. It photographed hills, drainage channels, and rocks made of water ice, all sculpted by rivers and rain of liquid methane and ethane. It is a dark, freezing cold mirror of Earth with a completely alien chemistry. Fact 52. Our first known interstellar visitor was a mystery. In 2017, astronomers detected something new. It was an object, but its trajectory was all wrong. It wasn't in orbit around the Sun, it was moving too fast, and it was on a path that clearly showed it came from outside our solar system. It was our first confirmed interstellar visitor. They named it Oumuamua, a Hawaiian name meaning scout, or messenger from afar. And it was weird. First, its shape. Based on how its brightness flickered, it was either shaped like a long, thin cigar or a flat, thin pancake. Second, it accelerated. As it swung past the Sun and headed back out of the solar system, something gave it a tiny, non-gravitational push. The most boring explanation is that it was a nitrogen iceberg, or a comet, and the push was from unseen jets of gas. The more explosive theory, put forth by Harvard astronomer Avi Loeb, is that its shape and acceleration were consistent with a light sail. A thin, manufactured object, a piece of alien technology, tumbling through our system. We will never know for sure. It's gone forever. Fact 53. A galactic year is 230 million Earth years long. We think of a year as the 365 days it takes Earth to orbit the Sun, but the Sun itself is not stationary. Our entire solar system is on its own, much grander orbit. We are in the Orion arm of the Milky Way galaxy, and we are hurtling through space at 828,000 kilometers per hour, 514,000 km. Even at that incomprehensible speed, the galaxy is so vast that it takes our solar system about 230 million years to complete one single revolution around the galactic center. This is known as a galactic year, or cosmic year. This timescale puts history in perspective. The last time our solar system was in this exact spot in the galaxy, about 230 million years ago, Earth was in the early Triassic period. Dinosaurs were just beginning to evolve. Mammals were tiny, shrew-like creatures hiding in the shadows. The time it took for dinosaurs to rise, rule the planet for 165 million years, and be wiped out, was less than one galactic year. Fact 54. The TRAPPIST-1 system has 7 Earth-sized planets. One of the most exciting discoveries in the search for life is the TRAPPIST-1 system, located about 40 light-years away. The star itself is tiny, an ultra-cool red dwarf, not much larger than the planet Jupiter, and it is orbited by a truly remarkable family of planets. Astronomers have confirmed 7 rocky, Earth-sized planets orbiting this star. Because the star is so dim and cool, their solar system is incredibly compact. All 7 planets orbit closer to their star than Mercury orbits our Sun. But the most exciting part is the habitable zone. Based on the light from the star, at least 3, and possibly as many as 4, of the 7 Earth-sized worlds orbit in the Goldilocks zone, the perfect distance where the temperature is just right for liquid water to exist on their surfaces. It is a compact, perfect laboratory for studying whether rocky, Earth-like worlds are in fact common in the galaxy. Fact 55. The moon smells like spent gunpowder. Here's another one you can only learn by actually going. When the Apollo astronauts were walking on the moon, they couldn't smell anything. They were in their suits, in a vacuum. The smell came after. When they finished their spacewalks and climbed back into the lunar module, they brought a huge amount of lunar dust, or regolith, with them. It was fine, like flour, and it clung to everything. Once they repressurized the cabin and took off their helmets, All 12 astronauts who walked on the moon reported the exact same, powerful, distinct smell. The lunar dust, now mixed with the cabin's oxygen, smelled like spent gunpowder or burnt fireworks. This is because lunar dust is not like Earth dust. It's not eroded by wind or water. It's sharp, abrasive, and unoxidized volcanic rock and silicon dioxide. When it was suddenly exposed to moist oxygen for the first time in 4.5 billion years, it had a sharp chemical reaction, creating an odor that no human had ever smelled before. Fact 56. The entire human race could fit inside a sugar cube. We think of ourselves and the world around us as solid, but this is a complete illusion. The stuff we are made of, atoms, is almost entirely empty space. An atom consists of a tiny, dense nucleus surrounded by a cloud of electrons, which are whizzing around in a vast, empty void. The scale is staggering. If the nucleus of a hydrogen atom was the size of a marble in the center of a massive football stadium, the electron would be a speck of dust flying around the outermost bleachers. Everything in between is empty space. Solid is just the sensation of your atom's electron fields repelling the electron fields of another object. You aren't touching your chair. You are floating just above it, repelled by electromagnetism. If you could magically remove all the empty space from the atoms of every single person on Earth, all 8 billion of us, the remaining stuff, all our combined nuclei and electrons, would be so dense it would fit into a volume the size of a single sugar cube. Fact 57. A water cloud with 140 trillion times Earth's oceans. We tend to think of Earth as the water planet and space as a dry, empty void. This is completely wrong. Water, H2O, is made of hydrogen, the number 1 element, and oxygen, the number 3 element, making it one of the most abundant molecules in the entire universe. We see it everywhere, in the ice of comet cores, in the rings of Saturn, and as vast underground oceans on moons like Europa and Enceladus. But the biggest reservoir of water ever found blows all of those away. Astronomers discovered an enormous cloud of water vapor surrounding a quasar, a feeding supermassive black hole, 12 billion light-years away. This single cloud of gas, floating in the early universe, contains an estimated 140 trillion times the amount of water in all of Earth's oceans combined. It is a body of water so vast it defies comprehension, proving that the ingredients for life have been present in the cosmos since the very beginning. Fact 58. Magnetars would rip the iron from your blood. We've talked about neutron stars and pulsars, but there is a third, even more terrifying variant, the magnetar. These are rare, mutant neutron stars with magnetic fields so powerful they border on science fiction. A typical refrigerator magnet is about 50-100 Gauss. A hospital MRI machine is a powerful 30,000 Gauss. A magnetar's magnetic field, a quadrillion Gauss. That's a 1 with 15 zeros after it. The power of this is not abstract. If you had a magnetar 1,000 kilometers, 600 miles away, the distance from London to Berlin, it would be so powerful it would rip the iron atom straight out of your blood cells, killing you instantly. It would wipe the data from every single credit card and hard drive on Earth from that distance. In 2004, a magnetar had a starquake on its surface. The resulting blast of gamma rays from 50,000 light-years away was so powerful it hit Earth and physically compressed our planet's ionosphere. They are, without question, the most terrifying magnets in the universe. Fact 59. The axis of evil is an uncomfortable cosmic anomaly. This is one of the most troubling and controversial facts in modern cosmology. When we look at the cosmic microwave background, the CMB, the afterglow of the Big Bang, it should be almost perfectly uniform with any hot or cold spots being completely random. But they aren't. Detailed maps of the CMB show large-scale patterns and alignments that are not random at all. There appears to be a large-scale alignment, a preferred direction in the universe. Scientists, with a sense of gallows humor, nicknamed this the axis of evil. The evil part is that this axis seems to be aligned with the ecliptic plane of our own solar system. This is a potential violation of the Copernican principle, the core idea that Earth is not in a special or privileged place in the universe. It suggests our solar system is somehow aligned with the entire cosmic structure, which makes no sense. Most scientists believe it's a massive statistical coincidence, a fluke in the data. But it remains a deeply unsettling mystery that, if true, would mean our entire model of the cosmos is wrong. Fact 60. One moon has an atmosphere, thicker than Earth's. We've visited Titan before, but this fact deserves its own spot. It is the only moon in our entire solar system to have a dense, substantial atmosphere. And it's not just a thin wisp, it's a beast. The atmosphere of Titan, Saturn's largest moon. It is mostly nitrogen, like Earth's, but it is so dense that the surface pressure is 1.5 times the pressure you are feeling right now at sea level on Earth. This high pressure, combined with Titan's low gravity, which is only 14% of Earth's, leads to a completely bizarre environment. The atmosphere is so thick and the gravity so weak that it's almost like moving through a liquid. In fact, the conditions are so perfect that if you were to stand on the surface of Titan in a very warm suit and strap a pair of simple homemade wings to your arms, you could fly. You could literally jump into the air and, just by flapping your arms, cruise over the methane lakes and icy hills of the most alien world we've ever touched. Fact 61. The Big Bang was not an explosion. This is the most fundamental misconception about the universe. When we hear Big Bang, we picture a bomb, a point of stuff that exploded in space, flinging galaxies outward into a pre-existing, empty void. This is completely wrong. The Big Bang was not an explosion in space. It was the expansion of space itself. There was no outside to the explosion. There was no center. Every single point in the universe was and still is the center. In the first fraction of a second, the universe was an infinitely hot, dense singularity. Then, space-time itself began to expand, carrying the energy and matter with it. The galaxies we see rushing away from us aren't flying through space. The space between us and them is stretching. A better analogy is baking raisin bread. As the dough, space, expands, all the raisins, galaxies, move further apart from each other, but none of them are at the center of the bread. We are living inside that expansion, right now. Fact 62. Panspermia is the theory that life came from space. Where did life on Earth come from? We have theories about a primordial soup where chemicals combined to form the first cells. But there's another, equally compelling theory, panspermia. This is the hypothesis that life exists throughout the universe and is distributed by seeds. These seeds could be microorganisms or just complex organic molecules, trapped in meteoroids, asteroids, and comets. These ships of life travel the galaxy, crashing onto new worlds and seeding them. It sounds like science fiction, but we know it's possible. We have found complex amino acids, a building block of life, on meteorites that have landed on Earth. We also know that some microorganisms, like the incredible tardigrade, water bear, can survive the vacuum, radiation, and cold of open space. It's entirely possible that Earth life didn't start on Earth at all. We may all be the descendants of ancient interstellar travelers. Fact 63. Jupiter's moon, Europa, almost certainly has a subsurface ocean. If we are going to find life in our solar system, the number one candidate is not a planet. It's a moon of Jupiter, Europa. Europa is a water world. Its surface is a shell of solid water ice, kilometers thick, and it's one of the brightest, smoothest objects in the solar system, crisscrossed with strange reddish-brown cracks. But the real prize is what's underneath. Data from the Galileo spacecraft showed that Europa's magnetic field is induced, meaning it's being created by a massive, moving conductor inside the moon. The only conductor that makes sense is a global liquid water ocean. This isn't a small pond. This subsurface ocean, warmed by the tidal flexing of Jupiter's immense gravity, is estimated to contain 2 to 3 times the amount of liquid water in all of Earth's oceans combined. It is a dark, warm, pressurized ocean that has existed for billions of years. If there is a second genesis of life in our solar system, it is almost certainly swimming in the dark oceans of Europa. Fact 64. Saturn's moon Enceladus sprays its ocean into space. Europa may be the #1 candidate, but Enceladus, a tiny, snow-white moon of Saturn, is a very close second. And it's doing something Europa is not. It's giving us free samples. In 2005, the Cassini spacecraft was stunned to discover that Enceladus is geologically active. Its south pole is covered in tiger stripes, 4 massive cracks in the ice. And erupting from these cracks right now are colossal geysers. Enceladus is literally spraying its own internal subsurface ocean out into space, creating Saturn's E-ring. Cassini bravely flew through these plumes, and what it tasted was astounding. Water vapor, salt, silica, indicating hot, rocky vents at the ocean floor, just like on Earth, and complex organic molecules. This means Enceladus has all 3 ingredients for life as we know it: liquid water, organic chemistry, and a source of heat. And we don't even have to drill through the ice to find out. We just have to fly through the spray. Fact 65. The heliosphere is our solar system's protective bubble. We don't just float in the galaxy. Our sun creates its own protective bubble that envelops all the planets. This bubble is called the heliosphere, and it's created by the solar wind, a constant, supersonic stream of charged particles flowing from the sun. This solar wind pushes outward for billions of miles, creating a safe zone in our corner of the galaxy. It pushes against the interstellar medium, the gas and dust from other stars. This bubble is what shields us from a huge amount of deadly, high-energy cosmic rays that would otherwise shred our DNA. The edge of this bubble, where the solar wind finally stops, is called the heliopause. It is the true, functional border of our solar system. We have crossed it. In 2012, Voyager 1 officially entered interstellar space, followed by Voyager 2 in 2018. They are the first objects humanity has ever sent into the great cosmic ocean beyond our home. Fact 66. Tabby's star baffled scientists with its alien megastructure behavior. In 2015, astronomers found a star, KIC 84628552, that was behaving in a way no star should. It was nicknamed Tabby's star after its lead researcher, Tabitha Boyajian. Stars dim, but in predictable ways. A planet passing in front might dim it by 1%. Tabby's star, however, was dimming randomly and massively. It would experience dips in brightness of 15%, even 22%. A 22% dip would mean something half the width of the star was blocking it. And it wasn't periodic like a planet. The data was so bizarre that a swarm of giant comets was proposed as the most likely natural explanation, which is itself an extraordinary claim. But the media and some scientists latched onto a far more exciting hypothesis: an alien megastructure. The idea was that an advanced Type 2 civilization, see Fact 72, was in the process of building a Dyson swarm, a massive constellation of solar collectors around their star, and we were seeing the shadows of these giant artificial structures as they passed. While the mystery is still unsolved, it remains the most anomalous star we've ever found. Fact 67. Wormholes are theoretically possible. Shortcuts. Through space-time, the universe is vast. But what if you didn't have to travel through it? What if you could take a shortcut? This is the idea behind an Einstein-Rosen bridge, more famously known as a wormhole. According to Einstein's general relativity, space-time is a fabric that can be curved. A black hole curves it into a well with no exit. A wormhole, theoretically, is a tunnel that connects 2 separate wells. You could enter a wormhole in the Milky Way and instantly emerge in the Andromeda Galaxy, 2.5 million light-years away. It's a beautiful idea, and it's mathematically sound. But there are problems. First, we've never seen one. Second, if they do form, they are predicted to be microscopically small and to collapse in on themselves in less time than it would take light to cross them. To hold one open, stable, and large enough to pass through, you would need a truly bizarre form of exotic matter with negative mass, which, as far as we know, does not exist. Fact 68. Time travel to the past is not ruled out by physics. This is where things get truly strange. We all travel in time, forward, at a rate of 1 second per second. And we know from Einstein, fact 36, that we can travel into the future by moving very fast or sitting in strong gravity. But what about the past? General relativity doesn't forbid it. The equations allow for solutions that contain closed time-like curves, CTCs. A CTC is a loop in spacetime. It's a path you could follow, perhaps through a wormhole, or around a spinning infinite cylinder, or near a black hole, that would allow you to travel through space and time and arrive at a point in your own past. The existence of CTCs is the very definition of a time machine. However, it leads to logical nightmares, like the grandfather paradox. If you go back in time and stop your grandfather from meeting your grandmother, you are never born. So, who went back in time to stop them? This paradox is so severe that many physicists believe a chronology protection conjecture must exist, a law of physics that prevents these paradoxes, and thus backwards time travel, from ever happening. Fact 69. Warp drive doesn't break the speed of light by cheating. The speed of light is the law. Nothing in spacetime can travel faster than light. But what if you could move spacetime itself? This is the principle behind the Alcubierre warp drive, proposed by physicist Miguel Alcubierre in 1994. It's a theoretical way to achieve faster-than-light travel without breaking any laws. Here's how. Your spaceship would sit inside a bubble of normal, flat spacetime. The drive itself would then contract spacetime in front of the bubble and expand spacetime behind it. You aren't moving at all. You're stationary inside the bubble. The bubble itself is being moved by manipulating spacetime. You'd be like a surfer on a wave. The wave, spacetime, is moving, but the surfer, the ship, is just standing still on the board. This would allow you to cross the galaxy in weeks, not millennia. The only catch? It requires a ton of energy, and, just like wormholes, it requires a ring of that same exotic matter with negative mass. Fact 70. A quark star is the next step beyond a neutron star. We know that when a big star dies, its core can collapse into a neutron star, fact 5, where protons and electrons are crushed into a soup of neutrons. But what if the star is too massive for even that? What if the neutron star collapses again? Theoretically, the neutrons themselves would break. The crushing gravity would overcome the forces that hold neutrons together, and they would dissolve into their constituent parts, quarks. The entire star would become a single city-sized supernucleus, a soup of free-floating up, down, and strange quarks. This is a quark star, or strange star. It would be even denser than a neutron star. We're not sure if they exist, but we have candidates. Some supernovae that were too bright might have been the birth of a quark star, and some pulsars that spin too slow might not be neutron stars, but quark stars in disguise. It is a new, exotic state of matter that pushes physics to its absolute limit. Fact 71. There are zombie stars that die twice. A white dwarf is the dead core of a star like our Sun. It's a cosmic cinder that has used up its fuel and will spend trillions of years just cooling off. It is, for all intents and purposes, a dead star. But sometimes it gets a second life, and a second death. This happens in a binary star system. If a white dwarf is orbiting close enough to a living partner star, its powerful gravity can feed on its partner, siphoning off a stream of hydrogen. This material builds up on the white dwarf's surface like a crust. This zombie star keeps feeding and feeding, packing on more mass until it hits a critical, unstable limit called the Chandrasekhar limit, about 1.4 times the mass of our Sun. At that exact instant, the entire star ignites in a runaway fusion reaction. In a matter of seconds, the entire star detonates in one of the most violent events in the universe, a Type 1a supernova. It comes back from the dead just to explode. Fact 72, the Kardashev scale, ranks civilizations by energy. When we look for aliens, what are we looking for? The Kardashev scale is a way to rank the technological advancement of a civilization based on the amount of energy it is able to harness. A Type 1 civilization is a planetary civilization. It can use and store all the energy available on its home planet, all the sunlight, wind, geothermal, and fusion power. We are not there yet. We are currently a Type 0.7 civilization. A Type 2 civilization is a stellar civilization. It can harness all the energy of its host star. The most famous theoretical concept for this is the Dyson sphere, or Dyson swarm, a megastructure that completely envelops the star to capture 100% of its power output. A Type 3 civilization is a galactic civilization. It controls the energy of its entire galaxy, harnessing the power of billions of stars and perhaps even the supermassive black hole at its center. To a civilization like this, we would be less than ants. Fact 73. The Great Filter is a terrifying solution to the Fermi paradox. We've discussed the Fermi paradox. Fact 38. The universe is vast and old, so where is everybody? The Great Filter is one of the darkest possible answers. This theory suggests that on the long evolutionary path from simple life to a Type 3 civilization, Fact 72, there is a wall or filter that is so difficult to pass, almost no species ever survives it. This filter could be anything. It could be the leap from non-life to life, or the leap from simple cells to complex cells. Or, more terrifyingly, the Great Filter could be in front of us. It could be a challenge that every advanced civilization faces, and which almost none survive. It might be self-destruction, like nuclear war or climate change, a technology we can't control, like artificial intelligence, or a natural event we can't stop. This theory leaves us with two chilling possibilities. 1. We are the first and only ones to have ever made it this far, or 2. We are next in line to face the filter that has killed everyone else. Fact 89. An observation now can seemingly change the past. If the observer effect, Fact 85, wasn't weird enough, let's talk about the quantum delayed choice experiment. This is a real experiment that will make your brain feel like it's leaking out of your ears. It's a variation of the famous double-slit experiment. In simple terms, you fire a particle, a photon, at a screen with two slits. If you don't watch which slit it goes through, it behaves like a wave and creates an interference pattern on the back wall. If you do watch, it behaves like a particle and just makes two clumps. The act of watching forces it to choose to be a particle. Here's the delayed choice part. What if you let the photon pass the slits when it should be a wave? And then, after it's already passed, you put up a detector to see which path it took? The photon has already decided to be a wave, right? Wrong. The experiment shows that if you look after the fact, the photon retroactively behaves as if it had been a particle all along. Your choice in the present seems to have dictated the past behavior of the particle. It suggests that at a quantum level, time is not a one-way street, and past and future are dangerously entangled. Fact 90. It is more likely you are a random fluke than that the universe exists. This is a philosophical nightmare called the Boltzmann brain paradox. It's a thought experiment that takes our understanding of physics to its horrifying, logical conclusion. We know the universe is likely to end in a big freeze, Fact 49. Becoming a cold, chaotic, empty void for trillions of years. But in that chaos, particles will still randomly bump into each other. Given an infinite amount of time, everything will happen. A monkey will type Shakespeare, and eventually, purely by random chance, a collection of atoms will assemble itself into a brain. This Boltzmann brain would be a fully formed, conscious mind, complete with a full set of false memories, of a childhood, of a life, of a universe that it thinks it lives in. Here is the paradox. In an infinitely old universe, the statistical probability of a single, conscious brain randomly forming in the void is infinitely higher than the probability of an entire, 13.8 billion-year-old complex orderly universe forming. This means it is statistically far more likely that you are a Boltzmann brain, just a fleeting, conscious fluke, and that I, this video, and the entire universe are just your false memories. Sleep well. Fact 91, the kilonova, where the universe forges gold. We know stars are element factories. Fact 25. But for decades, we had a problem. Even supernovas aren't powerful enough to create the heaviest elements, like gold, platinum, and uranium. So where did all the gold on Earth come from? We got our answer in 2017. That year, LIGO, Fact 39, detected gravitational waves from a new source. Not two black holes, but two colliding neutron stars. Telescopes all over the world whipped around to look at the source, and for the first time, we saw the explosion, a kilonova. This is what happens when two city-sized, 6 billion ton per teaspoon objects, Fact 5, smash into each other at a fraction of the speed of light. The explosion is so violent and so rich in neutrons that it triggers a process called R-process nucleosynthesis. It is a cosmic pressure cooker that, in a fraction of a second, forges all the heaviest elements. The kilonova we saw in 2017 is estimated to have created and ejected 16,000 times the mass of the Earth in heavy elements, including at least 10 Earth masses of pure gold. Every wedding ring, every gold coin, every platinum sensor was born in the single, most violent collision the universe can create. Fact 92. The universe is fine-tuned for life, and that's a problem. This one will keep you up at night. Physicists have realized that our universe seems to be balanced on a razor's edge. There are fundamental constants: the strength of gravity, the mass of an electron, the force that holds atoms together, that just are. But if you tweak any of them, even by a minuscule amount, the universe as we know it becomes impossible. For example, if the strong nuclear force was just 2% stronger, hydrogen would fuse so easily that the sun would have exploded billions of years ago. If it was 2% weaker, it couldn't fuse hydrogen at all, and stars would never ignite. If the force of gravity was slightly stronger, the universe would have collapsed back on itself just after the Big Bang. If it was slightly weaker, stars and galaxies would have never been able to form. It's as if someone, at the beginning, tuned all the dials to the exact setting required for stars, planets, and life to exist. Why? Is it a setup? Is this evidence of a creator? Or is it evidence for the multiverse, Fact 74, that there are infinite universes with bad settings, and we just happen to live in the one lucky one that worked? Fact 93. Earth has a second moon. Sort of. We have one moon. A big, loyal companion. But Earth's gravity is messy, and it occasionally captures temporary friends. We call them quasi-satellites. The most stable one we know of is an asteroid named Kamo-O'Alewa, a Hawaiian name meaning the oscillating fragment. It's a small asteroid, about 50 meters across, but it's in a very special corkscrew-like orbit around the Earth as we both orbit the Sun. It is, for all intents and purposes, a mini-moon. It's been orbiting us for about a century and will stay as our companion for a few hundred more years before its unstable orbit finally flings it away. But here's the truly bizarre part. In 2021, astronomers studied its light signature and found that it's not a normal asteroid from the asteroid belt. Its chemical makeup is a near-perfect match for our own moon. The leading theory is that Kamo'olawa is not a captured asteroid at all. It is a literal piece of our moon that was blasted off by a meteorite impact thousands or millions of years ago, and has been floating in a nearby orbit ever since. Fact 94. Life can survive in nuclear reactors, extremophiles. When we search for habitable planets, we are often biased. We look for worlds that are Earth-like, nice, comfortable, 20 degrees, with liquid water and sunshine. But life on our own planet has proven that this is a failure of imagination. Meet extremophiles. These are organisms that don't just survive in impossible conditions, they thrive in them. We have found bacteria, like Deinococcus radiodurans, living in the cooling pools of active nuclear reactors, happily soaking up radiation that would kill a human 1,000 times over. We've found thermophiles that live in the boiling hot, sulfuric acid-filled vents at the bottom of the ocean, with no sunlight, living on a diet of pure sulfur. We've found psychrophiles that live inside the ice of Antarctic glaciers. We've found life 3 kilometers deep in solid rock, living off the slow decay of uranium. These organisms prove that life is not a delicate flower. It is a stubborn, tenacious chemical weed. It doesn't need paradise. It just needs any energy source it can find. And that means habitable could mean almost anywhere. Fact 95. The Sun has a tail, like a comet. We've talked about the heliosphere, fact 65, the protective bubble our Sun's solar wind creates. For a long time, we assumed this bubble was spherical, like a ball. But recent data from NASA's Interstellar Boundary Explorer, IBEX, has shown us this is completely wrong. As our solar system moves through the interstellar medium, the thin gas of the galaxy, it creates a bow shock at the front, just like the bow of a boat moving through water. And just like a boat, it leaves a wake behind it. The heliosphere is not a ball at all. It's shaped like a comet. It has a long, streaming heliotail that trails behind us for billions of miles. This tail is not a single streamer, but seems to be split into 2 main lobes, shaped like a 4-leaf clover. We are literally swimming through the galaxy, inside a giant, invisible, magnetic comet. Fact 96. We are still in active communication. With a 1977 spacecraft, this is, in my opinion, one of the most incredible achievements in human history. In 1977, humanity launched Voyager 1. Its primary mission was to visit Jupiter and Saturn. It did that, and it just kept going. Today, Voyager 1 is over 24 billion kilometers, 15 billion miles, away. It is the farthest man-made object from Earth. In 2012, it officially crossed the heliopause and entered interstellar space. Fact 65. The void between the stars. And we are still talking to it. Its signal, traveling at the speed of light, now takes over 22 hours to reach us. A single ping, send and receive, takes almost 2 full days. Its computer has 240,000 times less memory than a basic smartphone. It is running on the fading plutonium-powered glow of a 47-watt power source, about the same as a refrigerator light bulb. And yet, this 47-year-old piece of 1970s technology is still dutifully sending us back data, our first and only live reports from the great beyond. Fact 81. Pluto's giant heart controls its entire planet. When NASA's New Horizons probe flew past Pluto in 2015, we expected to see a cold, dead, cratered ball of ice. Instead, we saw a stunning, vibrant, and geologically active world. And the most shocking feature was a giant, smooth, bright white heart sprawling across its surface. This feature, named Sputnik Planitia, is not just a pretty shape. It is a colossal 1,000-kilometer-wide basin filled with frozen nitrogen ice, and it is not solid. This is a living, breathing glacier of soft, slushy nitrogen that is constantly churning and convecting like a giant lava lamp. But here's the twist. This heart is so massive and heavy that it has completely reoriented the entire planet. Its immense weight caused something called true polar wander, literally pulling Pluto's crust so that the heart settled near the equator. This single glacier dictates the planet's entire atmospheric circulation, creating winds and sculpting landscapes. It is a massive, frozen, beating heart that controls the weather and geography of an entire world. Fact 82. Our moon may have had a twin that crashed into it. We've already established that the far side of the moon, fact 46, is not dark, but it is weird. It is dramatically different from the near side we always see. The near side is relatively flat, with vast, dark plains of ancient lava, the seas, or Maria. The far side, however, is a highland's nightmare, thickly crusted, mountainous, and covered in craters. Why are the two halves so different? A leading theory, known as the Big Splat, suggests our moon wasn't born alone. When the Earth was first formed, it may have captured two moons, not one. This twin would have been a smaller little brother moon, trapped in a gravitationally stable point behind our main moon. But stability, in the chaotic early solar system, doesn't last. Eventually, this smaller moon's orbit destabilized, and it began a slow, inevitable spiral towards the main moon, ultimately splatting into it in a low-speed collision. It didn't create a crater. It pancaked itself across one entire hemisphere. This big splat would have added a huge, thick second layer of crust, creating the mountainous, rugged far side we see today. Fact 83. The bright spots on dwarf planet. Ceres are fossil ocean volcanoes for a long time. The largest object in the asteroid belt, Ceres, was a mystery. But when the Dawn spacecraft arrived in 2015, it found something baffling. A dark, cratered world with dozens of spots of insane brightness. Most notably, in the Akator crater, it found a collection of spots so bright they shone like city lights in the dark. What were they? After years of study, we have the answer. Salt. But not just any salt. These are the fresh, leftover deposits from cryovolcanoes, or ice volcanoes. Ceres is not a dead rock. It is a fossil ocean world. Deep beneath its crust lies a vast, muddy, briny ocean of salty water. In the recent past, and possibly even today, this pressurized water has erupted through the crust, spraying a fine mist of salty water into the vacuum. The water instantly turned to vapor and ice, but the bright, white salt, sodium carbonate, was left behind, painting the crater floors. We are looking at the remnants of an active, salty, underground ocean in the middle of the asteroid belt. Fact 84. Spooky action at a distance is real. This is the one that bothered Albert Einstein so much he famously called it spooky. It's the phenomenon of quantum entanglement, and it might be the weirdest, most non-intuitive thing in all of science. You can create two particles, like electrons or photons, in a special way so that they are linked or entangled. They now have a shared existence. Let's say one spins up and the other spins down. The rules of quantum mechanics say that until you look at them, they are in a fuzzy, maybe state of both. Now, separate these two particles. Send one to the other side of the room or the other side of the galaxy. The moment you measure particle A, its maybe state collapses, and it becomes up. At that exact same instant, particle B, even if it's light years away, will instantly collapse and become down. It knows what happened to its partner faster than the speed of light. This violates locality, the idea that nothing can affect something else that fast. It's as if two coins, tossed on opposite sides of the world, always landed on opposite faces, with no communication between them. It's real. We do it in labs every day, and it's the basis for quantum computing. Fact 85. The act of looking at something can change it. Welcome to the observer effect, the most frustrating and fundamental rule of quantum mechanics. On the normal scale we live in, we can observe things passively. You can look at a baseball flying through the air without affecting its path. But on the quantum scale, the subatomic level, this is impossible. Why? Because to look at something, you have to interact with it. To see a tiny particle like an electron, you have to hit it with something, at least one particle of light, a photon. But an electron is so small and delicate that being hit by a photon is not a gentle observation. It's a catastrophic collision. The act of seeing it instantly changes its properties, like its speed or direction. This isn't a limitation of our equipment. It's a fundamental law of reality. You cannot measure a quantum system without fundamentally altering it. This leads to the famous Heisenberg uncertainty principle, which states you can never know both the precise position and the precise momentum of a particle at the same time. The more you know about one, the less you can know about the other. The universe at its core is fundamentally fuzzy and unknowable. Fact 86. The universe cheated to get rid of all the antimatter. This is one of the biggest mysteries in all of physics. The Big Bang should have been a moment of perfect symmetry. According to our models, it should have produced a perfectly equal amount of matter, the stuff that makes us, and antimatter, its evil twin counterpart. Antimatter is real. It's identical to matter, but with the opposite charge. When a particle of matter, like an electron, touches its antiparticle, a positron, they don't just collide. They annihilate each other completely, converting 100% of their mass into pure energy. If the Big Bang made equal amounts, then, in the first second of the universe, everything should have annihilated everything else, leaving behind nothing, just a universe full of light. But here we are. You exist. Your chair exists. The Earth exists. This means somehow the symmetry was broken. For every billion antiparticles, the universe cheated and made 1,000,000,001 particles of regular matter. That one leftover particle, that tiny rounding error, is what makes up every galaxy, star, and person in the universe. We are the leftovers of a cosmic civil war. Fact 87. The pillars of creation are already destroyed. It is one of the most famous, beautiful, and iconic images ever taken by the Hubble Space Telescope, the Pillars of Creation. It's a breathtaking portrait of 3 colossal towers of interstellar gas and dust, silhouetted against a glowing background. Inside these pillars, new stars are being born, which is why they have their name. Here's the cosmic gut punch. They are almost certainly gone. The pillars of creation are 7,000 light-years away from us. This means the image we are seeing is 7,000 years old. Fact 11. Observations from other telescopes, like the Spitzer Space Telescope, have revealed a massive, expanding shock wave of a supernova, an exploding star that is behind the pillars. Scientists have modeled this shock wave and found that it was due to hit and completely obliterate the pillars about 6,000 years ago. Since we are seeing 7,000-year-old light, this means the destruction has already happened. We are watching a beautiful, majestic ghost. The light from its destruction is already traveling through space and will arrive to update our night sky in about 1,000 years. Fact 88. We have detected fast radio bursts, and we don't know what they are. Imagine looking at the sky and, for a few milliseconds, seeing a flash of light. But not visible light, a flash of radio waves. A flash so powerful that in that tiny fraction of a second it released as much energy as our sun does in 3 days. These are fast radio bursts, FRBs. We first found one in 2007, and since then we've found hundreds. They are not a local phenomenon. The signals are smeared in a way that proves they have traveled for billions of light-years across intergalactic space. What is causing them? We have no consensus. The leading natural candidates are extreme objects, like a magnetar, fact 58, having a super starquake. But some are repeating. One FRB in a distant galaxy flashes on a regular 157-day cycle. This regularity makes the natural explanation more difficult. And, of course, that leaves the unnatural one. This is exactly what you might expect to see from the engine or beacon of an advanced Type 3 civilization. Fact 72. The mystery is wide open. Fact 97. The planet that is hotter than most stars we're used to are hot planets, like Venus, but they are nothing. Meet Kelt 9b. This is an exoplanet, a hot Jupiter, about 670 light-years away, and it is the definition of extreme. It orbits its massive, blue-hot star so closely that its year is only 1.5 Earth days long. Because of this, it is tidally locked, fact 46, with one side permanently facing its star, and that day side is heated to an unbelievable 4,300 degrees Celsius, 7,800 degrees. This is not just hot. This is hotter than 80% of all stars in the universe. It is hotter than a red dwarf star. It is so hot that its own atmosphere, which should be made of molecules like water or carbon dioxide, is completely vaporized. The air on Kelt 9b is a cloud of vaporized heavy metals. Astronomers have detected gaseous iron and titanium in its atmosphere. The planet is so hot that it is literally being evaporated by its own sun, streaming a tail of its own vaporized atmosphere into space. Fact 98. Empty space is a boiling, hissing soup of virtual particles. Let's go back to fact 1. Space is silent. But on a quantum level, this is not true. The vacuum of empty space, the nothing between particles, is actually a chaotic, bubbling, frenzied mess. This is the quantum foam. Thanks to the uncertainty principle, fact 85, the universe borrows energy from the future, as long as it pays it back very quickly. In this borrowed energy, virtual particles pop into existence from nothing, a particle and an antiparticle pair. They exist for a tiny, tiny fraction of a second before they find each other and annihilate, paying back the energy. This is happening constantly, everywhere, all around you, even inside your own atoms. Empty space is not empty. It is a hissing, boiling soup of potential, a sea of ghost particles popping in and out of reality so fast we can't see them. But they are real. We can measure their tiny collective push, which is called the Casimir effect. The void is, in fact, the most crowded place in the universe. Fact 99. The Great Silence is a terrifying solution to the Fermi paradox, XB. I've talked about the Fermi paradox, fact 38, and the Great Filter, fact 73. But there is another, perhaps more paranoid solution. It's called the Great Silence, or the Dark Forest hypothesis. The logic goes like this. Life is common. Intelligence is common. But the universe is a dark forest. In a dark forest, you don't know who is out there. They might be friendly, or they might be predators. If you are a hunter, you stay quiet. If you are prey, you definitely stay quiet. Any civilization that is loud, that broadcasts its existence into the cosmos with radio signals, like we are doing right now, is a fool. They are lighting a fire in the middle of the dark forest, screaming, "Here I am new, and I don't know the rules." This theory suggests that the sky is silent not because it's empty, but because it is full. It is full of ancient, intelligent, and cautious civilizations who know that the #1 rule of survival is to never, ever reveal your location. The silence we hear is the silence of fear. Fact 100. The universe is expanding faster than our theories. Although this is the final fact and it's happening right now. It's called the Hubble tension, and it is the biggest crisis in modern cosmology. We have two gold standard ways to measure how fast the universe is expanding. The Hubble constant, We can look at the early universe, the afterglow of the Big Bang, the CMB, Fact 59. This gives us a prediction. It tells us how fast the universe should be expanding today. We can look at the late universe by measuring the distances to nearby stars and supernovae. Fact 71. This gives us a measurement. It tells us how fast the universe is expanding today. The problem: the numbers don't match. The late universe measurement shows that the universe is expanding about 9% faster than the early universe prediction says it should be. This isn't a small error. It's a massive 5 sigma discrepancy that will not go away. It means something is wrong. Either our understanding of the early universe is wrong, our understanding of the late universe is wrong, or, the most exciting possibility, our model of physics is missing a new ingredient. We may be on the verge of discovering a new particle, a new force, or a dark component that is accelerating the cosmos in a way we never, ever expected.